Now let us see some examples which are based on the fundamental principle of counting. Here is the first question. How many 3-digit numbers can be formed using the digits 1, 2, 3, 4, 5 without repetition? So here we have 3-digit numbers. So let us visualize that. So there are 3 digits of the number, and we have to start counting by considering in how many ways we can fill in each of the place. Now here if we consider the leftmost place, we can fill that place in any one of the 5 ways because we have given the 5 digits. After filling that, the next position can be filled only in 4 ways because the question says that the digits cannot be repeated. And hence the last position, that's the units place, can be filled with any one of the remaining 3 digits. So using the principle of multiplication, the total number of numbers that can be formed is nothing but the multiplication of 5, 4 and 3, which turns out to be 60. So in all, 60 different numbers can be formed using these digits. Now let's see another sum. How many sequences of answers are possible in a test consisting of 10 true or false type of questions? So now if we look at this particular test, which has say 10 questions. So question number 1, question number 2, question number 3 and so on up to finally question number 10. Now once again, if you want to count the total number of different answer sequences, let's start one by one. So if you consider the first question, that can be answered in 2 ways, that is either true or false. So similarly, we have each of the remaining questions that can be answered in any one of the 2 ways. So therefore, in all, the total number of ways to answer the question paper is nothing but the multiplication of 2 into 2 and so on 10 times. So that turns out to be nothing but 2 raised to 10, which is nothing but 1024. So here once again we have used the principle of multiplication. Moving to the next question. The 10 students compete in a swimming race. In how many ways can they occupy the first 3 positions? So the first 3 positions means nothing but the first 3 winners of the race. So once again, if we designate the 3 positions by these 3 marks, so we have 1, 2, 3. So the 1 is the winner, second is the second runner-up and the third runner-up. Now as again once if we see there are out of 10 students, any one can win the race. So it's possible that there can be 10 possibilities here for the winner. Now whoever comes in the first position can obviously won't come in the next position. So therefore the next position is possible to be secured by any one of the remaining 9 students. And the last position can be done with the remaining 8 students. So hence the total possible combinations of these winners is nothing but the product of 10 into 9 into 8. So that turns out to be 720. Now here the assumption is that no 2 students can come together and finish the race. So that's the assumption. Let's move ahead to the next example. Using 7 flags of different colors, how many different signals can be generated if one signal uses 2 flags, one above the other? So if you imagine a signal which the question says that it consists of say 2 flags, one below the other. So this together makes up one signal. Now we are given 7 flags of different colors. So all the flags are of different colors and we want to arrange them any 2 one below the other. So let's start filling the places once again. That is, say this top position in the signal can be filled with any one of the 7 flags, and having placed one of the flags in top position, now the bottom position can be filled with any one of the remaining 6 flags only. And as we know, one signal consists of both the flags together. So therefore, in all, the total number of signals can be generated is nothing but the product of 7 and 6. So that is nothing but 42. So 42 different signals can be generated using the 7 flags of different colors.